Deltek Acumen Risck enhances project schedules by incorporating risk factors to create more realistic timelines compared to the traditional critical path method, which offers a deterministic, single completion date. Acumen Risck uses Monte Carlo simulations to provide a range of possible completion dates along with their probabilities, visualized through S-curves on a risk exposure histogram. Realistic adjustments. Acumen Risck adjusts project schedules for realism and provides completion dates with associated certainty levels. Monte Carlo simulations. It uses Monte Carlo simulations to generate multiple iterations, each influenced by different random factors, offering a probability distribution of completion dates. S-curve analysis. S-curves plot cumulative frequency of dates, allowing comparison of multiple risk-adjusted schedules to measure variance and investigate completion certainty. Application example. In a pipe repair project, the addition of a thrust block to stabilize pipe elbows is analyzed to determine its impact on the project duration with an 80% certainty level for the new completion date. Here displays the demonstration pipe repair schedule by itself. The pipe repair and improvement schedule, including the thrust block. Let us import both schedules into an Acumen Risck workbook. We choose S1 Project's Oracle Primavera single project from AP6XER file. We select the appropriate file in the resulting Open Windows Explorer dialog. In the Select a Primavera P6 project dialog, we again select the pipe repairs schedule. Note that an XER file can have multiple schedules embedded, we only have one. We choose Pipe Repairs and OK. This links the schedule to the Acumen Workbook 1. We want to import the second schedule. First, we left-click on the workbook, then again choose S1 Project's Oracle Primavera single project from AP6XER file. In the resulting Select a Primavera P6 project dialog, we choose the block schedule. Now both schedules are linked to the workbook. We then finish the import by clicking Import All Projects. The navigator pane with imported projects appears in here. We want to perform a risk analysis but must perform diagnostic analyses to confirm quality schedules before continuing with risk modeling. Proceed and click S2 Diagnostics, confirm the schedule quality is the active metric group, and click Fuse to analyze the quality of the schedules. The output of the schedule quality metric group analyses for each schedule is in here. The first row of metric group output in the last figure is the pipe repairs schedule, and the second row is the block schedule. We review the missing logic metric of the pipe repairs schedule by clicking its score box. The first and last tasks in the schedule are missing logic, which we would expect. Let us see if our schedule quality score improves when we remove the contract award date and project completion date from the analysis for the pipe repairs schedule, in the last picture, and the block schedule. We click to exclude contract award date and project completion date in the last two pictures. We then click the Fuse button to analyze each schedule's schedule quality metric group performance. The schedule quality metric group scores improved to 64% and 67% accordingly. They score better but have room for improvement. Both schedules fail the insufficient detail metric. It shows that tasks over 10% of the project's total duration failed the insufficient detail metric. The insufficient detail metric flags several tasks due to the short duration of both schedules. Let us make exceptions to these tasks and remove them from the analysis. The resulting schedule quality metric analyses appear in this picture. Now both schedules have a passing score, we are ready to model risk in our schedules. We continue and click S3 Risk. The pipe repairs schedule in the navigator pane defaults as the active. We set the duration uncertainty for the entire schedule to conservative. This indicates that the estimator considers the task duration estimates achievable or better. The risk register defaults to a negligible risk event. The pipe repair schedule has no risk events, so we leave this negligible risk setting. We then set the Run Risk Analysis scenario to Uncertainty and Risk Events, No Mitigation. We click the Run Risk Analysis button. The Monte Carlo analysis runs and outputs the histogram, S-curve, and tabulated data in here. We click the Add to Risk Comparison button to copy the S-curve to the risk exposure comparison. Continuing, we left-click the block schedule in the navigator pane. The duration uncertainty slider is again set to conservative. This pipe repair and improvement project includes the risk that the thrust block installation contractor is unavailable when required. To define this risk, we create the cement contractor unavailable risk event. We then map the risk event to the set forms task, which is the first activity in the thrust block installation process. The risk event probability is set to medium, 25% to 50%, and the schedule impact is set to low. Note in here that when we click the risk matrix button, we previously specified low schedule impact as 6 days or less. As before, we set the scenario to uncertainty and risk events, no mitigation. We click the Run Risk Analysis button. Here displays the histogram, S-curve, and tabulated output. We click the Add to Risk Comparison button to add the S-curve to the risk exposure comparison. We choose Right Panel Risk Exposure Comparison to display a graph of our results. We click between the two S-curves at the 60% cumulative frequency level. The risk exposure comparison of the two schedules appears in here. We click between the two S-curves at the 60% cumulative frequency level. This inserts a variance line between the two schedule plots to measure the delay from the thrust block installation. We repeat at the 80% confidence level. The resulting graph is displayed in the next picture. The first schedule result is the pipe repairs schedule and conservative duration uncertainty. The second plot is the block schedule, including conservative duration uncertainty and a risk event. Note the large increase in schedule duration we must accept for the assurance or certainty above 60%. Deltek Acumen Risk allows for the comparison of multiple project schedules by assessing risk exposure. Here's how it works. Import and link schedules. Model uncertainty and risks. Run analysis and compare.